So students, now we are going to start question paper 2014. So we will see one starting from 1 till 45. So let us solve one by one nicely. So first see number 1, I will tell you the answer. Solving part, as you know, you have to do it by yourself. So if it is needed to solve, I will solve for you. So question number 1, if force F, velocity v and time t are taken as fundamental units, then a dimension of mass r. What will be the dimension of mass? In the question it is saying that mass is taken as the dimension of force, velocity and time t. Let us take this one as a, b and c power. So what you are going to do, for mass we know on the left hand side it will be m1 l0 t0, right. For force, force is mass multiplied with acceleration, so m1 l1 t to the power minus 2, right. And for velocity we know l t to the power minus 1, and for time it is t. So you have to put power a here and then power b for this one, and this one will be power c. So you have to compare and find the answer. So when you compare this one, you will do it in this way. Let me show you one, m1 l0 t0. So m1, that means 1 into a is a, l a t to the power minus twice a, and it will be l b t to the power minus b, and this one will be t to the power c. So once you solve this part and compare the equation, your final answer will be option number 4. So option number 4 is the correct answer. Now let us move to the next question, that is question number 2. A projectile is fired from the surface of the earth with a velocity of 5 meter per second and angle theta with the horizontal. Another projectile fired from another planet, now it is not earth, with a velocity of 3 meter per second at the same angle follows a trajectory which is identical with the trajectory of the projectile fired from the earth. The value of acceleration due to gravity on the planet is, okay, given the acceleration due to gravity for the earth's surface is 9.8 meter per second square. Now one thing you need to know, that their trajectory, they are following the same thing, right. So if the trajectory is same, their range will be same. So I can say that range r1 will be equal to r2. So what you can write down as u square sine 2 theta, this is for one u1, divided by twice g of earth, and will be equal to u square, so it will be u2 sine 2 theta divided by twice of gp, this is for planet. So you need to calculate this, other values are known to you. So if you solve this one, the correct option for this one will be option number 1, that is 3.5. So question number 2 answer is 3.5. Now let us move to the next question, that is question number 3. A particle is moving such that its position coordinates x, y are given. 2 meter, 3 meter at time t equals to 0, 6 meter, 7 meter at time t equals to 2 second, and 13 meter, 14 meter at time t equals to 5 second. The average velocity from t equals to 0 to t equals to 5 second is, you need to calculate the average velocity. How do you calculate the average velocity? So what you do is, you can take the formula of average velocity is what? Displacement by time taken. Now how much is the displacement? The rate of change of position. Final position r2 let us take, and then r1 divided by final time is 5 second, initial time is 0 second. So you have the value of r2, that is this one. Find 13 meter and 14 meter. So you will do it in this way, 13 I cap plus 14 j cap minus r1 is this 2 I cap plus 3 j cap divided by 5. If you solve this one, your correct answer will come out to be how much? So let us solve it only. 11 I cap plus 11 j cap. So if you take 11 common, so your right answer will be 11 by 5 I plus j. This is the right answer for this question number 3. So now let us move to the next question, that is question number 4. Students, the question says that a system consists of 3 mass m1, m2 and m3 connected by a string passing over a pulley P. As you can see, it is a pulley question. The mass m1 hangs freely and m2 and m3 are on the rough horizontal plane. Therefore, they will have a friction and the coefficient of friction is given to us, that is mu. The pulley is frictionless and negligible mass. The downward acceleration of mass m1 is. So, assume that m1, m2 and m3 are equal, which is given by m. So, Newton laws of motion you have to apply here. You have to do it in this way. See, acceleration is equals to F equals to ma, right. So, mass, if F is equals to ma, then acceleration will be F by m divided by a. So, your force by total mass. So, force is your, this one will be mg, this one will be mg and this one due to coefficient of friction. So, mu mg plus mu mg divided by the total mass will be 3m. Fine. So, what you can do out here is mg minus mu mg minus mu mg divided by 3m. If you take the common as m, m will get cancel out and then from this one you will get the final answer as, if you take g common, number 3, g 1 minus twice of mu divided by 3. The rest part you will solve by yourself and see this is the answer which is coming. Now, let us move to the next question, that is question number 5. The force F acting on a particle of mass m is indicated by a force time graph shown below. The change in momentum of the particle over the time interval from 0 to 8 second is. Okay. You need to calculate the change in momentum, means you need to calculate the impulse force multiplied with time. So, how you are going to do it? You are going to find out the area covered by force and time. So, this is the first area, suppose this is the first area I am taking, this is the first area. So, how you are going to do it? So, this area will be half length into breadth, that is the triangle, half length into breadth, which is the triangle, plus it is in the negative side of the graph. So, it will be minus of what? It is a square or a rectangle, length into breadth, 2 multiplied with 3, 6 plus. So, this is in the positive side. So, it will be 4, that is 4 multiplied with how far it is going, from here till here is 6 and 4, fine. So, out here it is going till 3. So, 4 multiplied with 3. So, half length into breadth is the area of the triangle. So, half length and 6. So, it will be 3 minus 6 plus 12. So, 3 into 2 6, this one get cancel out. So, I have solved completely for you, that is 12. So, the answer is 12 Newton second. The impulse will be 12 Newton second, that is the change in momentum. So, final answer is 12 Newton second. This is for, we have taken 3 graph, this graph and finally this graph. I mean this area, what I am trying to say is. So, now let us move to the next question, that is question number 6. A balloon with mass m is descending down with an acceleration a, where a is less than acceleration due to gravity. How much mass should be removed from it so that it start moving up with an acceleration a? It is a good question from the mechanics part. It says that I have a balloon which was moving down, okay. So, it will have upthrust force maybe. So, if it is moving down, it will have mass mg, fine. If I make this equation for this one, it will be mg minus F will be equal to mass multiplied with the acceleration. Put it equation number 1. In the second case, what I have done is I have removed some mass, maybe some air particles from inside, and made it short a little bit. So now what happened? It start to move upward with the force. Okay. Now what will happen? F minus mg is equals to ma. Now the mass has been removed. It's a new mass. So how much will be the mass? F will be equals to F minus, not equal to. So I'll cut this line. So F minus, in place of this one it will be m, the original mass, minus m dash g will be equal to, this mass has been reduced, m minus m dash multiplied with g. Put it equation number 2. Now if you solve this question, your final answer is going to come as this one, twice ma divided by g plus a. So this is the correct answer for this question. Now let us move to the next question, that is question number 7. A body of mass 4m is lying in xy plane at rest. It suddenly explodes into 3 pieces. 2 pieces each of mass m move perpendicular to each other with equal speed. So the kinetic energy will be equal, but the total kinetic energy generated due to the explosion. So now third part, how much kinetic energy it had, we need to find out. So if you solve this one, how we are going to solve it? So V1 and V2, they are equal. Let's take it as V. Now using the concept of conservation of momentum, you will see that V3 is coming out to be V by root 2. Now use the total kinetic energy will be equals to, because of this one, half, because of velocity V1, half m v square plus half m v square plus half m v by root 2 whole square. So the total kinetic energy will be this. Fine. So at last your answer will be number 2, 3 by 2 m v square, right? So this is number 7. Now let us move to the next question, that is question number 8. The oscillation of a body on a smooth horizontal surface is represented by the equation x equals to a sin omega t, where a is the amplitude, x is the displacement at time t, omega is the frequency of oscillation. Which of the following graph shows correctly the variation of a with t? So there are the options 1, 2, 3 and 4. In the question it is saying that x is equals to a cos omega t. Now if you want to find out velocity, it will be what? Dx by dt. So how much you will get? Minus a omega sin omega t. Fine. Again, if you want to find out the velocity out of acceleration out of it, acceleration will be dv by dt. So you will get minus a omega square cos omega t. So with the help of this two, my graph will vary in this way. So graph will come in this way, right? So my right answer for this question is option number 3. So option number 3 is the correct answer. Now let us move to the next question, that is question number 9. A solid cylinder of mass 50 kg and radius 0.5 meter is free to rotate about the horizontal axis. A massless string is wound round the cylinder with one end attached to it and other hanging freely. Tension in the string required to produce an angular acceleration of 2 revolutions per second square is. Okay, I will just give you the formula for this one. This question came from the chapter, which one? Rotational motion or the rotational bodies. You can do it in this way. Torque is equals to I and this one is the angular acceleration. So you have to find what? Tension on the spring. So tension can be found out with the help of torque only. Force will be applied to it. So the right answer for this one is option number 4. Kindly do it and find it by yourself. That is 157. Now let us move to the next question, that is question number 10.